Welcome back, my dear children. Myself, Sir Sunil, your physics teacher. Good morning to all. How are you all? Fine? I hope you all are fine and also you are enjoying a long holidays. Okay, students, yesterday we have started one new chapter, new unit, force. Okay, from this chapter, today we are going to discuss a new point, effects of force. Okay, students, all of you please take out your book and watch carefully the video. So students, let's start our today's topic, effects of force. Yesterday we have discussed that what is force and how to apply force or when to apply force. We have discussed yesterday. When a force is applied on a body, it can have the following effects. First one, a force can move a body. A force can move a body. Yesterday we have discussed many situations, baby cart one, bullock cart one, and the example of a book, the moving book and moving car, and all we have discussed. In these all examples, we can observe that one common thing, the body is moving. Once we apply a force on a particular body, it moves. Okay, students, that is the first effect of a force. A force can move a body. Clear? Move a body originally at a rest. Second point is a force can stop a moving body. A force can stop while a body is moving. Just you touch it or you pull it, the body will stop. Okay, students, and another effect is a force can make a moving body to move faster. Another effect is a force can make a moving body to move fast. If we repeatedly push a body, a moving body, its speed will increase. Okay, so that is the third effect of a force. A force can make a moving body to move faster. Another one, a force can slow down a moving body. If a body can move fast by a force, then body can make slow down. A body can be slowed down while applying a force. Then fifth one, a force can change the direction of motion of a body. While applying a force, it can change the direction of the motion of a body. Okay. Then another one, last effect, that is a force can change the shape or size of a body. A force can change the shape or size of a body. Okay, from these 6 points we are going to discuss here today. First point, that is a force can move a body originally at rest. A force can move a body originally at rest. When a force is applied on a body originally at rest, if the body should be in a rest, if the body will be in a rest, the body begins to move. If you apply a force on that particular body, the body begins to move. For example, a car originally at rest when pushed begins to move. Suppose that a car in a stationary, a car in a rest position. If you push that particular car, what will happen to it? It starts to move. a grass roller. A grass roller when pulled begins to move. A ball lying on the ground moves when it is kicked. When a ball kicked, what will happen? The ball starts to move. And a grass roller when pulled, it begins to move. See, in these all situations, we can observe that the body is at rest. But while applying a force, it starts to move. Okay, students? Then finally, we can conclude that a force can move a body originally at a rest. A force can move a body originally at rest. It is the first effect of a body. It is the first effect of a force. Now, second one, a force can stop a moving body. A force can stop a moving body. When a force applied on a moving body in a direction opposite to the direction of motion of the body, it can made to stop. For example, a moving bicycle. We consider an example, a moving bicycle. Okay. It will stop applying the brake. We can stop the moving bicycle by applying brake. Okay. That is a familiar example for us. And also same way, bus, train also can stop while applying a brake. Okay, students, the brakes act against the direction of motion of bicycle, bus or train. The brakes act against the direction of motion of bicycle, bus or train. Thus, the brakes provide the stopping force. Thus, a brake provides a stopping force. And also a moving cricket ball. A moving cricket ball is stopped, that can be stopped by the fielder when he catches it. When he catches it, a moving cricket ball can be stopped. Clear? By applying a force. Clear? You can see the diagram. No need of diagram. It's cricket. You all like cricket. I too also like cricket. We know that how to catch it. Clear? We are applying a force. Clear? We are applying a force here while we catch. Now we are going to discuss a force can make a moving body to move faster. A force can make a moving body to move faster. When a force applied on a moving body in the direction in which it is moving, the body begins to move faster. For example, the speed of a bicycle increases when more force is applied on a pedal by the cyclist. If we apply more force on the pedal of the cycle or pedal of the cycle, what will happen to it? The speed of the bicycle will increase. To increase the speed of the bicycle, what we have to do? We have to give more force to the pedal of the bicycle. And also swing moves faster when a boy gives push to it. A swing, jula. Clear? A swing moves faster when a boy gives a more force to it, gives push to it. Clear? Here it is an example. Okay, students. Now a fourth effect of a force, that is a force can slow down a moving body. Third one we have discussed, a force can make a body faster. Same way a force can slow down a moving body. When a force is applied on a moving body in a direction opposite to the direction of motion of the body slows down or stops. For example, the speed of a moving vehicle is slowed down by applying the brakes. The brakes provide a force in a direction opposite to the direction of motion. The brakes provide a force of direction opposite to the direction of motion. That's why the body stopped. A swing can be slowed down if a boy, instead of pushing it, pulls. If you pull the swing, what will happen to it? It stops. If you push, it starts to move. If you pull, what will happen to it? It stops. Means we are applying the force opposite to the motion of the swing. That's why it stops the motion. Another one, a force can change the direction of motion of a moving body. If force is applied on a moving body in a direction other than its direction of motion, the direction of motion of the body changes. For example, a player kicks a moving football. Do you like football? Yes? Okay? We know how to kick the ball. Okay? Here, what the player is doing, a player kicks a moving football to change its direction of motion. A player applies force with a hockey stick to change the direction of motion of the ball. And hockey player, what hockey player doing? Player applies force with a hockey stick to change the direction of motion of the ball. Similarly, in tennis and badminton, the direction of motion of the ball or cork is changed by hitting it in opposite direction. Clear? Badminton, we know that how a badminton is playing. Doubles and singles are there. Anyway, both sides they are standing and we are hitting the cork. Suppose that from the opposite ground, one is hitting to us, what we will do? We will hit by our rackets to the opposite direction. Then what will happen to cork? Cork will move in opposite direction. So, by this example, we can conclude that a force can change the direction of the moving body. Okay, students? Here you can see one boy is kicking the ball. A player is kicking the ball. By applying the force, it changes its direction. So, now one activity here we can discuss. A force may change the direction of a moving object. Take a small piece of cardboard and hold it between your two fingers. Release it gently so that it falls down. While it is falling, strike the hard cardboard with another finger. You will notice that the board does not fall along the same path, but it falls somewhere else. Just keep the cardboard down, and on the direction of the movement you keep your finger in between. What will happen? So it is supposed to go down straightly down. It is supposed to go down directly, but by keeping in between our finger, what will happen to it? It changes its direction and it falls somewhere else. This happens because force applied by push of the finger changes its direction. Okay, now sixth one effect, a force can change the shape or size of a body. When a force is applied on a body which is not allowed to move, it gets deformed. That is, the shape of or size of body changes. For example, on squeezing a piece of rubber, its size changes. On stretching a rubber band or rubber string, its length increases on stretching a rubber band or rubber string, what will happen to it? Its length increases. It's this much small, but stretching it, its length increases. Here we can see a rubber piece squeezing. A force on rubber piece changes its shape. And also, if one end of a spring is tied to a hook and another end is pulled down by suspending a body, what will happen to spring? Its length increases. You see original spring, here it is. By suspending a weight to it, what happened? Its length increased. Its length increased. It was this much. Here is second diagram, we can see that its length increased. Now, do you know the increase in length of the spring in figure 3.11? Okay, you just observe 11 is directly proportional to the weight of the body suspended from it. On this principle, a spring balance works, which is used for the measurement of weight of a body. To measure the weight of a body, we are using the spring balance. Spring balance works by this principle. What it is? The increase of length of spring is directly proportional to the weight of the body suspended from it. So, from the above discussion, we can define the force as follows. Here is a definition of the force. We have discussed many things here yesterday also, today also. So, we can conclude the definition of the force here. A force is that cause which changes the state of body, either the state of rest or the state of motion or the direction of motion, okay, or changes the size or shape of the body. A force is that cause changes the state of body or changes the size or shape of the body. Clear? That is called a force. Here we have to note some points. A force does not change the mass of the body. A force does not change the mass of the body. Does not change the mass of the body on which it is applied. We cannot see force. Okay, we cannot see force. We cannot see force. Can you see force? We can feel it, but we cannot see the force. However, we can see or feel the effect of a force. Clear? However, we can feel the effect of the force. A force is expressed by stating both its magnitude and direction. A force is expressed by stating both its magnitude and direction. Two forces acting on a body in the same direction get added to give the resultant force, whereas two forces acting on a body in opposite direction get subtracted to give the resultant force the direction of a bigger force. Okay. Fifth point is, a body acted upon by two equal and opposite forces will have the resultant force 0. A body acted upon by two equal and opposite forces. If the force applying equal and opposite, if we apply equal and opposite forces, the resultant force that will be 0. Such forces are called balanced forces. Such forces are called balanced forces. A body acted upon by two equal and opposite forces will have the resultant force that is 0. Such forces are called balanced force. Next one, the SI unit of force is Newton. The SI unit of force is Newton. The symbol is N. Its gravitational unit are kgf and gf. its gravitational units are kgf and gf, whereas 1000 gf is equal to 1 kgf. Okay, 1000 gf is equal to 1 kgf. 1 kgf is equal to 10 Newton nearly. Okay, the SI unit of force is Newton. The symbol is N. Now we are going to discuss kinds of forces. Our topic is kinds of forces. Okay, students. Now it's a time to wind up today's session. Till tomorrow's session, goodbye and have a nice day.